Well, hello, good morning, and good afternoon to y'all. Welcome to Beyond Compliance. My name is Jim Albright, and I'm very happy to be with you today as we continue our journey into better understanding the influences, challenges, impacts, and solutions that surround the process manufacturing industry. And for those of you who may be new to the series, Beyond Compliance is designed to connect you to manufacturing industry experts who will share their perspectives on how to grow and improve business outcomes. And it also gives you a chance to interact with them and get your questions answered. So it's a really good series for folks to get direct answers on demand. That's what we're doing here today. All right, so this series has been going on for many years and is happily hosted by SafetyChain, who provide a holistic plant management platform that enable process manufacturers to improve yield, maximize productivity, and ensure compliance. It's pretty wonderful. Okay, so we have a lot of great content today, but before we get started, I just wanted to let you know that we are muting all attendee mics and we're leaving room at the end for Q&A. So please do submit your comments and questions into the webinar panel at any time during the session. And of course, this session is being recorded, and yes, you will receive that recording along with today's slides shortly later today. So, all right. Time to meet our speakers. We're very excited to have with us Chris Heim and Gage Gibson from AbeTech, a group that has a very long history of helping customers simplify how they get more out of their data by connecting the right machines, devices, people, processes, and so on to better enable deeper insights around mismitigation and optimization on your lines. So Chris, Gage, welcome to Beyond Compliance. I thought maybe you could provide a little background on AbeTech and give us a little brief of your experience before we dive into today's topic.
Hey, Jim, thank you. Hey, everyone, this is Chris Heim. I'm the president and CEO of AbeTech. And yeah, I just want to give you just a bit of perspective before I hand this over to our very intelligent and experienced Gage Gibson to take us through today's presentation. The perspective I want to give you is as you're looking at automating your plant operations, knowledge is power, and it can be overwhelming to basically go from wherever you're at today to where you're hoping to take your organization. And I just want to talk through a little bit of the philosophy that I have in running a business, and hopefully some of this is helpful for you. First of all, a partner like AbeTech, we live in the space of trying to simplify all the complexity of technology, and we're in the manufacturing, warehouse, and distribution area. The way that we try to bring technology to our clients is, first of all, it's a very people-first mindset, understanding people and what problems different leaders are trying to accomplish, what problems they're trying to solve. And as a trusted advisor, bringing engineering talent to the table and being very explosive in our responsiveness and trying to guide those things. And it's all about long-term mindset. So as you think about trying to improve the automation of the plant, data is the starting point, because the more data you have, the better knowledge you'll have on what problems are trying to be solved. And I love this idea of iterations of sophistication, that one of the most powerful things about data collection is you can start small, gather data, build upon that data, build business cases. And I think you're going to see this from Gage, and he has a really nice analogy with baseball to talk about how more and more statistics make you a better run baseball club. And that's how I view the opportunity for data collection within plant operations. So thank you for your time today. And Gage, I'd like to hand it off to you, sir.
Thank you very much, Chris. Hi, everyone. My name is Gage Gibson, and I'll be the main presenter today for the rest of the slideshow here. As Chris mentioned, I'm going to kind of have a baseball metaphor as our introduction here, but I really wanted to get everything started with a poll question here. So let me get over here to this first slide, and we want to know what is holding you back from collecting the type of data that you need. So we've got four answer choices there. If you wouldn't mind responding to that real quick, that'll help us get the conversation started here.
I love this question. Usually what holds me back is I didn't have lunch yet.
That can be an issue.
All right. Looks like we're almost at 60%, 70%. Okay, excellent. People are voting. Let's close the poll. and see what we got.
Okay. All right, this is actually exactly what I was expecting to see. Is I don't know where to start, and I'm the same way with a lot of things. I kind of get the analysis paralysis when I start looking at a problem. It's like, where do I even start to solve this? And that's really not surprising to me to see the results there. So that's good to know that a lot of you guys have the same type of experience as I am when trying to tackle a problem. Okay, so objectives for today. How do we justify collecting line efficiency data? Where do we start? Like I said, this is kind of what I was expecting to hear from you guys. We don't even know where to start. So what's a good way to get the ball rolling on collecting some data? And then we'll go through some real world examples of how we've done this in the past with some of our clients and some results that we've gotten through data collection. All right, so now here is the baseball part of this. I'd like to know, who would you consider the best player in Major League Baseball? We got 4 choices here: Aaron Judge of the Yankees, Shohei Ohtani of the Angels, Nolan Arenado of the Cardinals, and Sandy Alcantara of the Marlins. So hopefully we've got some baseball fans in the audience. If not, then I guess just pick whichever name you like, and we'll go from there. This poll question doesn't really have a whole lot of effect on the rest of the presentation. I just thought it would be a fun way to get things started here.
All right, we've got about 70%. I'm going to close the poll. Here we go. Let's show those results.
All right, let's see. Okay, so we've got a tie on Aaron Judge and Shohei, and then Nolan Arenado got a couple of votes too. Okay, so if you voted for Aaron Judge, I assume that you're probably voting for him because he hits a lot of home runs, or maybe you're just a Yankees fan, which there's a little bit of bias in this poll question, I'm sure. Shohei Ohtani has the intrigue of being both a great pitcher and a great hitter, so he brings value to both sides of the ball. Nolan Arenado is more of a well-rounded player where he's very good on both offense and defense. And Sandy Alcantara is probably the best pitcher in the league right now. He didn't get any votes here, but that's the reason why he was included on this list. So I want to start this introduction here and just talk about how Major League Baseball teams have really elevated their scouting and analysis game by improving the way that they collect data. So for a long time, the best way to answer the question of who is the best player was just through counting statistics: home runs, who had the highest batting average, who has the most strikeouts, that type of thing. But Major League Baseball is taking advantage of technology to collect data from practically every movement that occurs during their games. So back in 2015, they began using what's called StatCast in all 30 Major League ballparks, which is a combination of camera and radar systems that allows for the collection and analysis of a massive amount of data from every single thing that goes on in a baseball game. So instead of those counting statistics that we're talking about, StatCast allows us to see data like exit velocity, catch probability, sprint speed, and even spin rate for every single pitch, hit, and play in every game. Yes, they can count how many times a ball spins on its way to the plate when the pitcher throws it. That's kind of crazy. And this all allows us to quantify the raw skills of the players in ways that were previously unavailable to us. So right now you may be asking yourself, that's all great, but how does this relate to my production line? And to answer that, it's like, so back in the day when we were awarding the batting crown to whoever happened to have the highest percentage of hits, whoever had the highest batting average, we didn't necessarily have the data to tell us that there was a better way to measure what was considered productive play. So just like Major League Baseball is using better technology to scout and analyze its players, you can also leverage technology to find those profitable opportunities in your plant. You just need better data to show you where to look for it. And that's what we're trying to accomplish here, is like, how can we use the equipment and machinery that we already have in our plants to collect data and find opportunities for either better productivity, some cost savings, whatever's going to make our business better in the long run. So let's go ahead and move on to why collecting data matters. We can operate with a reduced workforce often. A lot of times with these machine interfaces that we're talking about collecting data from, This is just free data that's already being generated by these machines that you have in your plant. It doesn't require any labor force to collect this data. It's all taken through a connection to the machine itself. So a lot of times we can just collect this data directly into our quality management system, and there's no extra work needed there. We can remove human error or fraud. You know, we love our work, our labor force on the floor, but a lot of times, you know, somebody might write something down wrong. Somebody might have a transcription error, might have illegible handwriting that then gets put into the database or a spreadsheet or whatever. Things happen. But if we're getting the pieces of information from the machine, we know this data is exactly as it should be, and we also have a time and date stamp in most cases coming from that machine telling us exactly when that data collection happened. So that can be very helpful for, you know, checks on, for instance, metal detectors. If we're having to run our test pieces through the metal detectors at the beginning of each shift to make sure they're in compliance, we can know with 100% certainty that that test was done on time with a time and date stamp coming directly from the metal detector. And then real-time data increases reliability of results. So data is great, but data in real time is better. And that's a point that I'm going to make, especially with temperature collection later in this presentation, that having this data available immediately after it's collected can help us make decisions that will prevent problems from happening before they happen, which would be huge. Okay, so if you were in San Diego for the SafetyChain Customer Summit this year, this might look familiar to you. This was the AbeTech sponsor table at that event, and I just wanted to kind of go through a couple of points here to outline a little bit of what I'm going to be talking about later in this presentation before I get to it. So this was our OEE setup at the user conference there. And we're using these banner sensors that SafetyChain has adopted to collect data for their OEE module. So what we're doing here is we have this little kid's marble run, but it just so happens that this marble run has a battery-operated elevator that takes the marbles from the bottom all the way back up to the top, and has a little bit of perpetual motion here. So we use this to simulate a production line where the marbles coming up, the elevator there are raw product entering the line, and we're watching that with that yellow sensor there at the bottom. And then we have another sensor towards the end of the line where we're counting finished product going across the packaging area of the plant. So if we go on to the step 2 here, this is actually the SafetyChain OEE module that is showing this data that we're collecting. And you can see the red lines at the bottom are times of downtime, and the green lines are times of uptime, and those correspond to the speakers at the event. So anytime that we had somebody actually talking and presenting, we would turn these marbles off and allow downtime to take over, and the OEE module would document that. And then anytime that we had a break and people were coming over to our table to see what we were doing, we turn it back on, and those are the green areas where we're actually getting counts there. And in addition to just counting numbers, we're also getting, you know, average run rates, you know, downtime specific to each line, you know, all sorts of important information that that you can't really see on the screen there, but it's a lot of data that's being collected and presented in the SafetyChain OEE module there. And then finally, we have our metal detector interface, which I'll get into in depth here towards the end of our my presentation here. But this is one of our interface boxes that could connect to a piece of machinery on the floor, and you can see we're doing a HACCP check on the metal detector to make sure that our machine is in calibration before we start. And if you see the big screen over there, we're getting a pass once we get all of our good readings off of there. And then we also have one of our wireless temperature probes there, and I'll get into some temperature taking towards the end of this too. So here is our mock-up of a meatball plant. So as you can see here, we've got a whole bunch of little colored dots that are potential areas of data collection that we could tie into. So we have an orange dot anytime that we have a mounted temperature sensor. We have a red dot wherever we have a wireless gateway or a Wi-Fi access point. We have a blue dot anytime we have one of our machine interfaces. We have a green dot wherever we have a touchscreen computer that we're working with. We have a purple dot wherever we have one of our big screen scoreboards. And we have a yellow dot wherever we have some sort of handheld input, whether it be a handheld temperature probe like it's pictured there, or that could also be a digital caliper if we're taking measurements of our product. Just some sort of handheld input that we're doing QA checks with typically. So we're going to start off in our cooler and receiving area, move on into blending and grinding, put our product on the floor scale, move into the production area where we've got a former and a blast freezer. And then you can see the little meatballs going down the line through the bagger, through the checkware metal detector, across the taper, and into the freezer. So scenario 1, we're going to be talking about our production area. Scenario 2, we'll move on into the packaging area. Scenario 3, we'll be talking about taking temperatures, mostly ambient. And then in scenario 4, we'll be talking about doing a fully cooked product in a meat plant. So let's go into scenario 1, our production area. Right here, we have our floor scale. We're weighing our product before it goes into the line to make sure we know exactly what we're starting with, because how can you know how well you're doing at the end of the line if you don't know what you started with? So we have a temperature sensor where we're monitoring the ambient temperature of the room. That's talking to one of our wireless gateways or Wi-Fi access points. And then we have our product coming across the floor scale where we have a touchscreen computer running our quality management software. We get a weight directly from the scale, and we're telling it that we're going to send that to line 1. It's product 1, 2, 3, 4, 5, so that we know further down the line this is what we started with, and we can tie that into our finished product that we're done with that we get at the end of the line. So the touchscreen computer here is mostly for user input. A lot of times we can, if we're just worried about getting weights here, we don't necessarily need an HMI of any sort. We can get those weights directly from the floor scale. We have scales that can connect directly to the Wi-Fi network, and we can send those data points to the database or cloud without any sort of human interface. But it's nice to have a computer touchscreen, a human machine interface here where we can actually tell metadata about that product before we send it off. So all this is connected to the network, sending data. The temperature probes are typically set to send on a timed interval, and that goes to our cloud for viewing later. Now, if we move on into the production area here, we have our Meatball former that has one of our machine interface devices, and that's also talking to a wireless access point. And there's all sorts of data that we can get from this type of machine. So we can get a running or idle message from the machine status, whether there's product actually running. We can get machine speed and cycles per minute, which is very valuable information for doing stuff like OEE. And then just the presence of product exiting the machine, so that we know even if the machine is on and cycling, maybe there's not any product there. We're not actually getting any product flow coming out of the machine. So we know, we can tell with some sort of photo sensor there if there's actually product leaving the machine, even if it's cycling. So I've been working extensively with SafetyChain on installing some of their OEE solutions, and this is a perfect example of a place to collect start of line in counts. Is on a machine like this where we're tied into it, we're collecting cycles per minute, and we know that each time that this machine cycles, we're getting X amount of product out. So for the Meatball example, maybe we're getting 6 meatballs every time the cycle. So we'll count that coming directly off the machine, and then we'll tie that into the SafetyChain OEE module to know that we're getting that many pieces of product for every cycle. And then on the wall in the same room, we have one of our scoreboards. So this is just a mock-up of something that we would typically do for this area of the plant. SafetyChain also has plenty of built-in dashboards in their system that we could present on this as well. So just a cell for each line. We've got a running status or idle status, feet per minute, speed of the conveyor, what product's running, input weight, package weight, loss of production, OEE score. The sky's the limit on this type of stuff. Once we have this data in our system, we can present it any way we want, and we've even got temperatures on there on the right side of the screen coming from the devices on the wall to know that there's any sort of trend going out of order there. So these scoreboards are nice for showing the users on the floor what's going on while the production's happening. And again, all this data is coming in real time, so these numbers are updated live, and every minute, every 30 seconds, whatever timeline makes sense for you. So now we're going to move into the packaging area. So in here we have a bagger, and this maybe you don't have a bagger on your line, maybe you got some sort of other packaging machine. It really doesn't matter here, because a lot of times we can tie into this with the machine interface and get data from the PLC that's on this machine. So things like run status, drops per minute, total weight produced, average package weight. These are all data points that are produced by these machines that you probably already have in your plant. You just don't have a way to necessarily collect them easily. And that's what we're here to do. We want to get all this data that's free to you. It's available. You just don't have a good way to collect it. So one of our machine interfaces connected to the Wi-Fi network, sending out data on every bag that's produced in the bagging machine. And then we move on to my favorite area is the detection equipment, the checkwares, the metal detectors. There are so much awesome information that we can get from these. So again, tied into the machine interface box, we can get data from the checkware where we're recording every weighment if you want to. Like we can literally weigh every single piece of product that goes over this checkware. I know a lot of times we don't necessarily need all that data, and that's the key to why we want to use one of these interface machines, because we don't necessarily want to overload our database with a data point for every single piece of product that goes over the checkware, but maybe we want to put that data inside a historian table so that if we, for whatever reason, need to go back and take a look at that, we have it. But really all that we're sending to the cloud is just min, max, average type of data, so that we're not necessarily overloading our system there. And then for the metal detector, we can get the output from the metal detector will let us know every time that we have a detection coming from that machine. So I like to bring up a lot of times, like, you have a metal detector, yes, it rejects the bad product, but like, how do you know who knows when that happens? A lot of times, if you're not tying into your metal detector, all that happens is there might be a light that goes off or a horn that blows whenever there's a reject, but you don't necessarily have anything in your database telling you how many of those happened throughout the day, unless you're actually taking note of all that. So we can get a data point for each metal detection that happens from each of your metal detectors, a timestamp of when those things happen throughout the day, and then also confirmation of the product rejection. But the really cool thing is we can put our interface boxes into a mode where they're expecting to see the test pieces that you run throughout the day to make sure that your metal detector is in calibration. So that was what I was showing in the video from the user conference earlier. Is we can tell the metal detector, okay, we're about to start our HACCP check. It'll ask for the ferrous piece, it'll ask for the non-ferrous piece, it'll ask for the stainless piece. It can even test the reject mechanism after we do that, and it'll send a data packet to our quality management software saying that, okay, at this time and date, we did our HACCP check, it was good. So there's no more writing that on a pad of a clipboard with a pen and typing it into a Excel spreadsheet or a database later. All that information is coming directly from the machine as it happens in real time. So that can really be a nice thing as far as liability goes. And then we come to our box counts and downtime tracking at our beautiful tape machine here. So this is near and dear to me because, like I said, I've been doing a lot of OEE installations with SafetyChain over the past few months. So we have one of those yellow sensors that you saw in the video there attached to the tape machine here, counting boxes as they're produced. If we want to have a touchscreen computer for entering in downtime events at this location, we could do that too. So we have our box coming across the machine. It gets sealed, it gets counted, and monitor box counts, user input during downtime events. Okay, we have a downtime event. The tape machine got a clog in it. We have the ability to type in or select from a drop-down menu really a cause and action and a timer counting the amount of downtime that we've accumulated because of this. And this is all built into SafetyChain's OEE module, and their software handles all this stuff really well. And then again, we have our scoreboards in this area where we can have some data about the boxes produced and a Pareto chart for our downtime tracking here. So we can have a line-by-line Pareto chart of what our total downtime was and what our main bad actors were and how much each one of them was responsible for. And then we also just have data like, total pounds produced, total cases produced, average case, giveaway, OEE, like I said before, once we get this data into our system, the sky is really the limit on what we can report on and see here. And now we're moving into scenario 3, which is our temperature monitoring. This is another one that I like. So we have our handheld temperature probe here that's taking temperature of our product at the receiving dock, just to make sure that this product that we're receiving is up to our quality standards before we actually put it into production, because it's really hard to make good product if the raw materials are not up to your standards. So it's you got to check that beforehand to make sure that the temperature is right and that product's not bad. Ambient temperature using one of our wall-mounted devices and a wireless gateway, of course. So as I said, the temperature probe is used to check temperature of incoming product before it's accepted. That way we can send it back if it's not right. Taking temperature of the room while where they're installed at preset timed interval, and each unit can be programmed individually so that certain rooms can be taken on a certain time interval and others can be at a different time interval. So if you have a room that needs to be monitored more closely, that's totally possible with our temperature system. And it goes to the plant management platform. And then we have this nice little temperature dashboard of the manager's office that we mocked up here. Like I said, SafetyChain has all sorts of beautiful pre-programmed dashboards and SPC charts and that type of thing that you can use on use to view all this either on your computer or on your phone on the go. And nice XBAR and range chart of the freezer temperature there to make sure you're not trending out of line. Okay, and our final scenario here is fully cooked temperatures. So for as most of you probably know, especially for chicken here, we have to get up to a internal temperature of 165 degrees to ensure consumer safety, and we're testing that constantly to make sure we're not trending out of whack with our cook temperatures. So if you're selling by the pound, overcooking results in lots of products out the smokestack, because the more that you cook this chicken, the less it's going to weigh. But of course, liability protection pushes toward overcook, but profit concerns push toward the undercook. So we want to make sure we've got got our control limits such that we're cooking this chicken as close to the 165 marker as we possibly can without having too much liability and risk of an undercook. So we use one of our handheld temperature probes here to test the pieces as they're coming out of the oven to make sure they're up to temperature. And we actually have real experience of a huge money-saving endeavor here that we did with exactly this scenario. So we were able to correlate the temperatures of the cook oven at one of our customers to the temperatures that we're collecting with our handheld temperature probes, and present it with a nice XBAR range chart showing the calculated control limits that you can see on the screen there. So using statistical methods, we were able to have that 99.7% Six Sigma certainty that all of our internal temperatures are going to be above the food safe level. So we were able to adjust the set points on the oven to where we were very comfortable with the fact that we're going to be within not only within the control limits, but above the 165 degree threshold for fully cooked food safe, ready to eat food. And you can trigger alarms to be raised based on data trends, allowing for the set point adjustment before unsafe product is made and frozen. So that's the key. We want to make sure that we catch this before we actually have a problem. So using these methods and the fact that this data is available in real time, we're able to find these problems before they actually occur and become an even bigger problem. So if we're trending out of whack, we can know that as these temperatures are being taken instead of finding out after the fact and having to do a recall. And that we were able to save, in the magnitude of millions of dollars by correlating these temperatures to the oven temperatures and making sure that we achieve the fully cooked temperature, but also being as close to that threshold as we can safely be. So that's kind of the gist of my presentation. I've taken you through our plant here and taken a look at some places where we can collect some easy data using the equipment that you probably already have in your plant. So ways that you can make the most of your data is, of course, the plant management platform. We got to put this data somewhere. You've got to have some sort of backend software that you can store this data in a database and have those charts and graphs available to you to make these decisions that you need to make based on the data that you're seeing. So getting the data is only half the battle. You have to put it somewhere that you can reliably use the data afterwards. And then AbeTech has our plant scoreboards that we can display that data on the plant floor so that people actually managing the production can see what's going on in real time and make adjustments as needed to better the process. And then, like I said, automating the collection data is a big key. Not only are we doing it in real time, but we're doing it such that we don't necessarily need a whole lot of labor force to collect this data. A lot of this data is available from your machines that you already have. We just need to be able to tie into them and collect it and put it in the spot where we can use it. So one final poll question for you guys is, what area of your plant has the most potential value for data collections? We've got the receiving, line start, product temperatures, ambient temperatures, and packaging/detection.
That's a really good question. Curious to see what we see as the leader here.
I am too.
All right, we'll just give it a little bit more time, just a couple more seconds for everybody to vote. And all right, we're going to close that poll down. Let's see what we have.
All right, ooh. Product temperatures.
Yep, clear front runner. There it is.
Yeah.
Wow.
Well,
okay.
Gage, this was incredible. Obviously, you did a great job kind of walking us through the process, looking at where we can extract certain data points, and then showing us what we can yield from those insights. And Chris, again, what you said earlier was honestly profound and helpful in terms of, hey, there are definitely strategies around how you build your business, and obviously getting those insights is a big part of that. So I wanted to kind of kick things off. Just talk about like your experience at AbeTech. When you get somebody on the call, what is the traditional, we'll say, fire that's happening? And I can imagine that what that fire is actually not the root cause of their biggest challenge. What's the main reason people call you? And B, what is typically the root cause of those issues in terms of connecting data points, visualizing and analyzing data points, and then obviously using that information to make quicker decisions?
So Jim, I'll just start out here. I think oftentimes, management intuition is important in business. We know our companies and we have a feel for what's going on, but management intuition sometimes isn't enough. And if you have the discipline to also go on a search for, let's just call it the digital truth of, of finding data that either confirms your management intuition, or sometimes we have an opportunity to learn things that we just absolutely didn't know or didn't see about our company. So I would say that we love having conversations when it's more about exploring assumptions on either a problem that seems like it might be fixable, or just this feeling that there's more opportunity to extract out of the company. That's a wonderful place to start before you even get into technology, is just getting in tune with what you feel is the potential in your business. And any good advisor, that's the best place to start. And maybe Gage can chime in. And I'd also like to introduce, Bob Richards, who's with us today as well, who has, significant industry experience that can share a few insights. Gage, would you like to add some more detail to that?
Sure. Yeah, I think along with the poll question here, it seems like more and more these days the calls that we're getting now that we have these temperature taking devices is kind of how can we successfully use what you have to make sure that we're collecting what we need to collect on the temperature side. And one thing that I didn't mention, we've had success in the past of, in addition to using our handheld temperature probes to monitor the fully cooked product temperatures as they're coming out of the oven, we've also had processes that are doing like a kind of a sous vide style cooking in water type of thing. And there's a huge need there for real-time temperature data, because if they have some sort of temperature deviation there, they could track the product temperature throughout the entire process, which is different than running a piece of meat through an oven. So it's a very unique opportunity to track that product temperature throughout the entire cooking process and really find potential problems before they even start. And that's a really interesting way that we're able to help people out collecting data there. So.
Yeah, and I'll just add to that, Gage. Thank you. So I just was listening, but I'm here to help answer some questions. And I've been with AbeTech a couple of years, but before that, I spent most of my career in a food manufacturing and IT, and I was led the team that did data collection on our side too. And I think our biggest challenge we ran into there, and we see this with our customers too, is really wanting to tackle everything at once and trying to bite off more that they can chew right away. And really what we found is incremental value is so much more powerful if you can prove the value of one use case across the company and really start getting that value from the solution right away. The quicker then you can add to it and continue to add to the value to the system or the program in order for you to continue to kind of get funding to continue on.
Right, that makes sense. Since kind of the theme of this presentation is around boosting output with current resources, and there's a lot of, we'll just say, root causes around why you have limited resources, but we won't get into that. But generally speaking, yes, we need to do more with less. And Gage, as you mentioned, you have this pool of data that is valuable if you only know how to use it. So just generally speaking, do you find that it's true that one of the biggest challenges is that folks don't exactly know what types of data to extract and then how to manipulate it or analyze it effectively to make operational improvements?
Yeah, absolutely. I think that people know what they want. They just don't know how to get what they want with what they have available to them. And that's a lot of times when we're doing introductory data collection of plants, is figuring out how we can get to the end of the road with what we have available to us at the beginning. And sometimes that's a challenge. It's not always ready out of the box with what we have available. Sometimes we have to add some pieces to it to get to where we want to go. But more often than not, we can ultimately get to that destination with a little bit of help.
Yeah, I could just see a bunch of folks sitting in a boardroom, right? All right, how do we improve operations? Well, let's talk to the quality folks. Let's talk to the safety folks. Let's talk to, X, Y, and Z type of departments. And everybody has different maybe definitions to what their KPIs are. Do you find that to be true as well as you're working with clients? Is there sort of a need for better alignment around some key performance indicator definitions or some other type of metrics that the organization uses to track success?
Yeah, that absolutely. I think a lot of times everyone kind of has the same vision of where they need to go, but they kind of stumble over each other because they're using different words to describe the same type of thing. And being able to solidify internally exactly what our goals are and how we're going to achieve those, what KPIs we're really after, is a huge first step before you even start collecting the first piece of data. Is just getting one solid approach that you can all agree on before you get started.
Yeah, never easy. It sounds easy, but it's actually not. Um,
No,
how
not at
about
all.
folks that are working on a line, right? So these folks, and generally speaking, we do hear a lot of stories about manual processes still being done at the plant level, lots of paper-based processes, right? Which are well, we feel they're very prone to risk. But either way, how does connecting data better enable line workers, floor managers, and above, right? As we move up the chain, I guess, within the organization.
Well, Jim, I'll chime in just for a bit of high-level thinking on this. One of the realities that we face across the industry is a shortage of labor, and this will probably be our reality for many, many years to come. And so, this people first strategy second mindset that we take is, most of my career implementing technology has been about displacing labor. But in an environment like we are today, where there's a shortage of labor, I think technology takes on a different role in that it can help enhance the work that people are doing and help people do better work, help elevate them to do new types of jobs and automate those things that are manual or dangerous or just mundane. And so I think that spirit of technology is awesome, because if we can bring technology to the plant floor in a way that it's helpful to plant workers versus threatening, now we can create an environment where we're helping everyone do their job better. And with that mindset, if you can help a plant worker understand the data that goes along with their job so they can do it better or maybe rethink it, I think it just opens up a totally new conversation than maybe the way that technology was perceived when it was brought into a plant, I don't know, maybe 5-10 years ago.
Yeah, and
Yeah, kind of.
I was just going to add that what we also see is sometimes when we drive these big initiatives, we forget that line worker, right? And giving them that data. So that's why you see Gage, emphasize that we can create scoreboards and these dashboards and things that the operator can get instant feedback, not just pass it on for the larger compliance and or analysis, but also for immediate feedback. And that's a big focus of ours, to help all the way down to that plant level worker find some value in that data and why we're collecting it.
Yeah, absolutely. And then obviously enabling folks to be more assertive and be mindful of, that real-time data. And then obviously that benefits everybody, right? It rises all the boats when you see an issue more proactively using that real-time data in front of you. It obviously has a ripple effect that benefits everybody. So um, you guys had mentioned, or Gage, you were talking about the example of fully cooked temperature where you had a 99% confidence that it was cooked. One question came in around, can you expand on that a little bit? Was that by compliance standards, or was that by what you saw was sort of
So,
the best way to cook that chicken or whatever it was
so
in order? Yeah.
yeah, sorry, I thought you're done. I didn't mean to interrupt you there at the end, but the 99.7% is a SPC standard. So whenever we have the Six Sigma, the 3 standard deviations of either side of the mean, once we're out to 3 standard deviations, which is where our calculated control limits said we were, then we can be 99.7% certain that the next data point will fall between 3 standard deviations high and 3 standard deviations low of the mean. So when we have all this data that we're collecting, then we have that much certainty that the next data point is going to be in line with what we've already produced.
Got it. And another question, I guess, around data points. You had shown a screen which showed downtime over time. I forget which slide it was, but essentially it was kind of a really cool bar chart that showed your different lines, and then the cumulative number of minutes or time that was caused by whatever issue over the course of a day or what have you. That was pretty powerful. So the question was around how do you actually build something like that? Is that baked into one of your displays that you guys showed, or is that something you have to custom build?
So that's called a Pareto chart, and a Pareto chart is again an SBC type of chart where you're showing line by line breakdown of not necessarily downtime, but just like kind of the total that you have accumulated broken down into pieces of what is contributing to that accumulation. So if in the instance of downtime tracking, we're taking a look line by line of how much downtime total we have, and then breaking that down into what is causing us to have that downtime. So I believe that Pareto charts are included in the SBC charts of SafetyChain. Don't quote me on that. I'm not a SafetyChain employee, so I don't know the software as well as they do. But I believe that Pareto charts are included there.
You do get Pareto charts in SafetyChain, yes.
Okay, yep. Cool. I thought that was the case, but I just wanted a disclaimer. But yeah, for our plant forward dashboards, we could include that as a built-in chart as well.
Yeah, it obviously shows, if your line keeps going down, even if it's for 30 seconds, 1 minute, obviously that cumulative view of seeing all of that downtime, that means money. That means obviously risk of non-compliance, and it's a very powerful tool.
Yeah, and you can even correlate those downtime minutes to dollars if you want to, and that'll really open some eyes when you do that.
Yeah, exactly, and that kind of goes back to your example where you were saying you saved this one organization millions just by tracking temperatures. That one metric is,
exactly,
as you mentioned earlier, an extremely valuable data point that you can optimize.
Yeah, that allowed them to be confident that they could lower the temperatures of their oven, still achieve the HACCP temperature that the product is going to be safe to eat, but then have more pounds of product at the end of the day because they're not overcooking it.
Exactly. Well, Bob, Gage, Chris, thank you so much. That's all the questions I see coming in for now. So we're going to move on to this final screen here, where if you enjoyed this presentation, there's a lot more information out there from AbeTech, from SafetyChain. You can see some web addresses up there for you to check out some of those resources. Obviously, we would love to hear from you. So please do email us or check us out from our websites and enter into the chat. We're here to respond and help answer some questions for you. So please do take the time to do that if you have any questions following this presentation. Again, big thanks for the AbeTech crew. We love having you on. We hope to have you again. And obviously, thank you to everybody joining us today at Beyond Compliance. We definitely wish to see you very soon and the next Beyond Compliance happening in September. So we'll look out there. Have a great rest of your day, everybody. Thanks again for joining us.
Thank you, everybody.
Thanks, everybody.
Thank you, everyone.